Good morning, everyone. Today we're going to look at application of differential calculus in finding maxima and minima. In particular, we're going to learn how to solve some of the maximum and minimum problem. So before we venture into solving maxima and minima problem, we need to understand what is this turning point. This turning point is also called as sometimes as stationary point. Now, how do we define turning point? A turning point can be defined as a point from where the nature of the curve changes, or it is a point on a curve where the first order derivative is going to be equal to 0. So this is how we define a turning point. So there are three turning points. Those are maximum point, minimum point, and inflection points. So basically, what we're going to do is we're going to basically find these 3 points. Now, before we go into conditions of a turning point, let us look at what are maximum, minimum, and inflection point. If I take an example of a graph, let's say you have a graph with this axis, and let's say you have a curve of this nature. This curve, if I draw a curve in this manner, the curve is an increasing curve. The nature of curve is an increasing curve. Now let's say from this point the direction of the curve is changing. Let's say it is changing in this manner, and this is a decreasing curve, and let's say this curve is decreasing till this point, and from this point let's say the nature of curve is again an increasing, right? So if you consider this portion of the curve, if I consider this portion of the curve, you see this curve is changing its nature from this point, right? And if you take all the points from this curve, this would be the highest point, this would be the big point. So this point is called maximum point. Likewise, this curve is decreasing. This curve is decreasing, and it is still decreasing, and this would be the minimum point. This would be the furthest point till where this point is decreasing. So this point is called minimum point. This curve is called minimum point. Now, if you look at this portion of the curve, this portion of the curve is decreasing till this point, and from this point this curve will assume to have different nature, right? So this point is called inflection point. Sometimes this inflection point is also called as saddle point. So these 3 points together we call it as turning point or stationary points. Now let us look at the condition. Let us look at the conditions one by one. So let us go with condition of maxima. So if you are solving any maxima problem, this condition that I'm going to write need to be satisfied. The first condition is dy by dx is equal to 0. Now, what is the physical significance of this dy by dx? In physical world, this dy by dx would mean slope, meaning here slope should be equal to 0. So at this point, at this maximum point, and at this point, and at this point, if you try to find a slope, the slope at this 3 point is going to be 0. But for now we are talking about maximum point, so slope at this maximum point is going to be 0. Now the second condition is second order derivative. If you find second order derivative at this point, the second derivative at this point is going to be less than 0, or in other words it's going to be negative. This is condition for maxima. Let us go with condition of minima. The first condition is going to be similar to maxima condition. The slope at this minimum point is going to be equal to 0, and the second order derivative at this minimum point, the second order derivative at this minimum point is going to be greater than 0, meaning it is going to be positive. Likewise, let us look at a condition of inflection point. This is the third point. The condition for inflection point, the first condition would remain same, meaning at this point, if you try to find the slope at this point, is going to be 0. The second condition is here, when you find second order derivative at inflection point, the condition is the second order derivative is going to be still 0. In addition to two conditions that we had in maxima and minima, here you're going to have 3 conditions. The third condition is the third order derivative at inflection point is not going to be equal to 0. So this is the additional condition that we have in inflection point.